How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for 21.1 radioactivity. So what are atoms with radioactive nuclei called? They're called radioisotopes because they are isotopes that are radioactive. All right, number 2. Which type of radioactive decay has the atomic number of the product go up by 1? So let's take a look at some examples. There's alpha decay, where let's say you start with uranium with a mass of 235. And if it's alpha decay, it gives off an alpha particle, which has a mass of 4, a charge of 2, which is basically a helium nucleus. And then, hey, what's left? Well, if we're balancing the charges, 92 on the left has to equal 92 on the right, so the missing product has a charge of 90. And if we take a look at the mass, same kind of thing. 235 has to equal 4 and, well, missing mass of 231. Look up what element has a charge of 90, and it's thorium. So it's not going to be alpha. All right, well, let's take a look at our beta decay. So an element that goes through beta decay could be like carbon 14. Carbon charge of 6, mass of 14. If it goes through beta decay, it gives off a beta particle, which has a charge of -1 and a mass of 0. So our new element, the missing product, well, let's see, 6 has to equal -1 and 7. What element has a charge of 7? Nitrogen. Let's check the masses. 14 has to equal 0 and 14. So there we go. Well, what happened to the charge here? Well, hey, it looked like the charge of the product went up by 1. So our answer is going to be beta decay. But let's take a look at the rest of some of the decays. For example, we have positron decay or positron emission. So one element that can go through that would be like oxygen 15. So it has a mass of 15, charge of 8. And it gives off a positron, which has a charge of +1 and a mass of 0. And then let's see, what would our missing element be? Let's see, 8 has to equal 1 and 7. So we got nitrogen. And the charge, or the mass, has to equal 15. And let's see, 0 and some number gives me 15. Boom. And then last, let's take a look at gamma emissions. So TC99M will give off gamma rays. But what gamma rays are is it's not actually a particle, it's just a high energy photon. So it has a charge of 0 and a mass of 0. So the numbers don't really change in this example, but a gamma particle is given off, or gamma ray. Number 3, what is element E in the following nuclear equation? So again, you have to balance the masses and balance the charges. So I got bromine, then an arrow, some missing element, and a positron, right? It's got a +1 charge, a mass of 0. So let's see, the charges, 35 has to equal some number and 1, so my missing charge has to be 34. The mass, 75 has to equal some number and 0, so the mass is going to be 75. So what is that? SE. You look up what is the atomic number that of 34, or what element has that atomic number, and there you go. Number 4, fill in the blanks for this reaction. Well, let's see. I got 15 has to equal 16 and some number. This one can be tricky. It's got to be a -1. 32 has to equal 32 and some number, 0. So what's the missing thing? It is an electron, aka a beta particle. There you go. Number 5. What happens to the mass and charge of radioactive nucleus that undergoes alpha decay? So again, let's see. If it gives off alpha decay, well, the alpha particle has a charge of 2. So whatever the charge is on that unknown thing, it has to be 2 less. It's got to go down by 2. And the mass, well, let's see. The alpha particle has a mass of 4. So the mass of the new thing has to go down by 4. Right? So mass goes down by 4. And the charge goes down by 2. All right, I hope you found that helpful. See you in class. Goodbye.